Welcome everyone to Educquiz. We are on the second exercise on partial fractions, which goes by x plus 1 into 2x plus 1 divided by x cubed minus 1. We have to represent this into partial fractions. So in your equation, we have x plus 1 is 2x plus 1 all of x cubed. Okay, so how do we go about this? If I say checking the numerator's degree is less than the denominator's degree, it don't have to be equal to the numerator as be less. So the numerator's degree here is 2x. When they will multiply, the highest degree will be 2. So we consider the degree of this is 2. What is the degree of the denominator? Not just period. So the numerator's degree is less. The second requirement is this denominator has to be factorized. Is this factorized? No, it is not factorized. But can it be factorized? So people will say no, but if you know your identities, like a squared minus b squared is a minus b into a plus b. This is the difference of two squares. Here we have the difference of two cubes. Can we say that this is the difference of two cubes? Here I can see that I have x cubed minus 1 cube. Yeah, 1 square, 1 square. This also a cube. So do I have an identity like this for difference of two cubes? I have to know an identity like this for difference of two cubes. It exists. I'm going to write it here. A cube minus b cube is equal to a minus b. A minus b into a squared plus ab plus b squared. This is the remarkable identity for a cube minus b cube. So that is key in solving this, because without this you cannot solve it. If you know this, you cannot solve this. I think it's in the formula booklet. Yeah, for those writing in opacity. Yeah, it's in the formula booklet. But well, as a mathematics student, you have to know these identities offhand, because when you're writing in class, you are not writing with the formula booklet. You are lecturer, you are teacher, and give you this. So you have to know this. So using this second identity, I consider here my a is x and my b is 1 q. All you made that as it says a minus b, a is x minus b is 1 into a is x. We shall continue to write a here about x, b, comma a squared is x squared plus ab x times 1 is x plus b squared 1 squared 1. So this is a denominator actually. This under here. So here you can see that this. You can see that this is equal to this divided by this, which should be this where we expanded x plus 1 into x plus 1. All on, we have x plus 1 into x squared plus x plus 1. So, when you have done this, if you have been following, consider as from here, if you already get this, it's already quite this. That was just the tricky part there. So, how do I continue from here? The first two requirements are done. The first requirement says you should make sure that the degree up is less than the degree down. The highest degree up here is 2. The degree down here is 3. I can see that in one bracket, the highest degree is 2. In the other bracket, the highest degree is 1. Add the degrees, you have 3 because they normally multiply. As a matter of fact, it was x cubed. The degree here is 3. So, the first condition is fulfilled. The second condition, we should make sure that the denominator is factorized. Here we just factorized it. So the second condition is supposed to fulfill. The third thing that we have to do is to represent in our partial fraction form. If I am to represent this in my partial fraction form, how would it? This will be equal to what? In partial fraction, this will be equal to, for this, I have a on x plus 1 for this plus, what is this? This is a non-factorable quadratic equation. How is it non-factorable quadratic equations? As we said that was the, I think it was a third or second, maybe one of the two types of, it was a third type of partial fraction. Partial fraction make quadratic equation at the denominator, non-factorable quadratic equation at the denominator. You see, this is a quadratic equation, but it cannot be factorial because you cannot factorize this. So what do you do? We do, to know that, how do I know that I cannot factorize this actually? Well, if you don't know whether you can factorize or not, try yourself to factorize. Try yourself and see that you cannot factorize. So to try to factorize this, I'll use my formula method. I know that from the formula method, I have x equal minus b plus or minus square root of b squared minus 4ac on 2a, where a got a in this case is the coefficient of x squared 1, b in this case is the coefficient of x 1, c in this case is the last number 1. So all of it is 1. Let's solve and see whether we have a value of x which is valid, which is not a complex number. A complex number is something like square root of negative 1 or square root of negative something, like that will be complex number. So let's solve. If you have values of x like this, we know that it does not exist. Otherwise, for complex number, so it is a set of complex numbers. So let's solve and see. We have minus b, it is minus 1 plus or minus square root of b squared 1 squared, which is 1, minus 4a is 1 into 1, c is 1, 1. All of that divided by 2a is 1. That will lead us to 1 plus or minus square root of 1 minus 4 times 1 times 1 is 4. 1 minus 4 is minus 3. How it works. Here we have square root of minus 3. Square root of minus 3.
Is that talking about instead of use
that's what I says in real numbers.
to get the context by actually we use ESS count. How do you try the excess count?
3 times square root of minus 1. So it does not exist. So I'm going to use this in real numbers. So far, let us see. When you do this, I see that you have square root of this negative number. Do that, this cannot be factorized. So that is how by so. Because I've been solving, I know from the ceiling that I cannot be factorized. But if you don't know, try and solve it by formula method. Yeah, we'll see, but it cannot be factorized.
Oh, is it?
Oh, when I can factorize complete, equals bx over c. No, that's x squared plus x plus 1. So from here, I think it comes. All there is to do. I guess right. You find your LSM passport one day how you have x plus 1.
X squared equals IC so yet level it's what the we actually to look at is a nice scout.
So for when you have the Isaiah, you need to get this number usually by this time with this. So you have a into this divided like this. X plus 1 cancel x plus 1 about it, and we'll be left with x squared plus x plus 1. You write here x squared plus x plus 1 plus, to copy this, you put your bracket here, bx plus c. See, when you deal with bx plus c, you always put your bracket. If you don't put your bracket here, I need it because many students do this. If you don't put your bracket, it means what you're multiplying here will multiply just c. The bracket means what is next affects all what is inside the bracket. So if this is multiplication that next, it affects everything inside the bracket, not just the one right here. If it is division, it affects everything in the bracket, not just this one. Because if you remove the bracket, when I do this, I'll write maybe x here. The x here multiplies just this c. Because you do not say that you multiply c and bx. If you put this in your calculator, yeah, you have the answer of x multiplying just c. It is the same thing if you put division sign here. The x here will divide just c. So, when you put your bracket, means all over this in the bracket is insufficient.
Just sign up as
So,
let go.
you have vx plus c. What do we have inside the bracket? We will have all of this denominator divided by this. When we divide all of this by this, we will see that this and this are going to cancel, will be left with x plus y. So, we write x plus y. So we write the x plus y, you can copy this part. And then nothing changes here. So I'm going to copy it back. X plus 1 into 2x plus 1 and boom. X plus 1 into x plus h plus 1. So how do I proceed from here? I do, as you all know, I do the cross multiplication. When I do the cross multiplication, this one will come here and this one will come here. And then I can cancel this one which is here with this one which is here because they're the same actual. I can cancel it. So I'll be left with just the numerators, which will be 3 things. So when I'm left by numerator, what do I do? I I'll have x plus 1 into 2x plus 1 is equal to, I write my numerator here, a into x squared plus x plus 1 plus bx plus c in bracket into x plus 1. So what do I do here? I have 3 unknowns a, b, and c. So for me, I can continue either by comparing, expanding and comparing the values, expanding and comparing the coefficients, or I can continue by substituting values, letting x be something, then find a, b, and c. So any of them will go here, but I will let, I choose to let. So to find a, what will I do? To find a, I don't really want to solve, you know how to solve and do it. So to find a, I can use my cover up method. So when I do x minus, when I do, what value of x will I put here for this term to be 0 on a? I can do the cover up method just on this. I cannot do it to be here. So I have to continue to find this. So when I do my cover up method, I can do it just on partial fraction with linear factors as denominator. Here you can see that this is a linear factor as denominator. I can do it here. Or you can see something normally, the answer will be the same. So if I do my cover method here, I see that when I put minus 1 here, minus 1 plus 1 is going to be 0. So the value that I will use to do my cover method is minus 1. How did I find minus 1? X plus 1 is equal to 0. I just equate this to 0 and I find x. X will be equal to, when this one comes in, it becomes negative, I have x as minus 1. So when I have my x plus minus 1, I can actually use that minus 1 here. I cover off this x plus 1 and I use minus 1. When I use minus 1 here, I'm seeing that minus 1 plus 1 make all of this be 0. Actually, because minus 1 plus 1 is always 0. If I use minus 1 here, whatever the value is going to be 0. But the numerator is 0. Any number which is 0 divided by any number down here is going to give 0. So a is 0. If you doubt the cover method, let's just solve. Let's solve here normally. I'll find. Okay, if I am to let, I'll let the first value I will let is I check here what I have put here that will give me 0. Nothing, I can put nothing here and that will give me 0. What can I put on this second factor that will give me 0? So when I put as x, it will give me 0. You saw here previously it was -1. So -1 is the first value that I'm going to use because -1 may eliminate all of this. So the second value that we'll use is 0 and the third value that we use is math. Because those are the two very simple values that I know how to use. So I'll first let x to be equals to -1. So letting x to be -1 here. -1 here will be so letting x to be -1 here, we have minus b plus c plus into minus b plus c into -1 plus 1. I even forgot this. -1 plus 1, return all of this to 0. So if I have times 0 here, you can see that as I said before, all of what is inside this bracket is going to multiply this 0. Because 0 is also inside the bracket. Even if it was not inside the bracket, since 0 is alone, there's no other value. 0 is multiplying all of what is here. So all of this is turning to 0. So we are left with this. 1 minus 1 is 0. 0 plus 1 is 1. You can see that 0 is equal to a. So a is 0 just as we did it on our cover-up method. We can see that a is actually 0. So the cover-up method is really way simpler. So with a being 0, we can proceed and find b and c. So to find b, I'll let x to be 0. And I let x to be 0, I put 0 into the equation. Our 0 plus 1 is 1. 1 times anything is 1. So when I put 0 here, 2 times 0 is 0. I'll be left up with 1. So I have just 1 times 1. 1 times 1 is 1. I have 1 is equal to my a is 0. A is 0 here. So a 0 times anything is 0. All of this thing will go. So I put in bx. I put 0 here. B times 0 is 0 plus c. I'll be left just with c inside this bracket. So I'll be left with c inside the bracket. C into x is 0. 0 plus 1 is 1. C into 1. It implies c is equal to 1. Yeah. So I do my third letting. I let x to be equal to 1. When I let x to be equal to 1, I replace here. I have 1 plus 1, 2. 2 times 1, 2 plus 1, 3. 2 times 3 is 6. I'll choose to leave it like that first. And it is equal to a times anything is 0 because a is 0. So I all of this will return to 0. X is 1, so I have b plus c. B times 1 is b plus c into here I have x as 1. 1 plus 1 is 2. From here I can say that these 2 can cancel here. I can divide both sides by 2. This will go, this will go. So I'll be left with b plus c equals 3. B plus c here equals 3 is 3. So since b plus 3 is equal to 3, I have c as 1. b equals to 3 minus c, which is equals to 3 minus 1. C is 1, which implies b is equal to 2. So we've had our values. A is 0, b is 2, c is 1. So we're happy. So when we have our values, we write the final answer as this way. You replace the values of A and B and C here. So we're going to do that there. So we have this is equal to A is 0. So all of this is going to go. B is 2. So I write 2x. C is 1. So I write 2x plus 1 on dot x squared plus x plus 1. So this is the final answer. What I omitted to do is I could just cancel here. I didn't see that really quick. You're going to solve just this with this. That is why A was 0 actually. You cancel here, this will disappear. We'll be left just with this and this. The answer will still be the same. Well, it will not take much time to find A, fortunately. So yeah, this is what we are going to have. We have just this. That will be the answer there. You could just cancel at the beginning. It would have been way easier. So that's the final answer. So we are done. Thank you for watching this video, the second exercise on partial fractions in Educquiz. So we invite you to continue watching. Keep on with the videos on Educquiz, and for instance, you can watch exercise 3 and see how it goes. So thank you for watching this video and thank you for being faithful to Educquiz.